Hello, Machine Shop math fans. This is, I do believe we're going to call this video 4. However, the file number may change later on, but this is basically a recap for fractions. You should have, if you did what you were told to do, watched all those Khan Academy fractional videos and done some of the assignments at the end of each video. There's some short question and answers that give you an instant answer when you do those Khan Academy videos. So we're going to do a little recap. We're also going to introduce the degree of precision, and we're going to carry this over into machine land, which the Khan Academies are not necessarily. They're not machining centric. It's just general math, and Sal Khan does a wonderful job. Khan Academy is an amazing resource in today's connected world. So let's do a little recap here. We have a fraction. I guess we need to get a marker. Maybe we'll try black. I think everybody can see black. Okay, if we have 1 to 4, or it's 1 to 4, that's the same thing as saying 1 over 4. This is a relationship. It is 1 to 4. 4 is our language. So 4 over 4 would equal a whole, 1. This just happens to be one part of something that's divided into fourths. The number on top is called the numerator. The number on the bottom is the denominator. Denominator. Okay. Now, we get the word denomination from the root of denominator. It is the base of something. So in the U.S. it would be $1. Okay, that's the denomination, U.S. dollars. Okay, in Vietnam it's a dom. Germany it's a Deutschmark. France is a franc, and so forth and so on. So anyway, that's the denominator. So 1 over 4. Now, 1 over 4 is called a proper fraction. Proper fraction. Okay? And why is it a proper fraction? Because some evil math nun in history said that that's a proper fraction. Now me, I don't care about being proper. I enjoy being improper. Now, if we had 4 over 3, that's referred to as an improper fraction because the numerator is greater than the denominator. Now, I could care less. I like improper fractions. As an engineer, as a carpenter, as a machinist, as a riflesmith, if I'm having to deal in fraction land, I like improper fractions. They're a whole lot easier to deal with than a mixed number because 4 over 3 is the same as what? 1 over 1 1/3, yes? Now, this is referred to as a mixed number, okay? So, 4 over 3, or 4/3, is 1 1/3. And why is that? If you remember your Khan Academy, 3 over 3 equals 1. But in this case, we have 4/3, yes? 4/3. So, if we take 3/3, which is a 1 from there, that leaves us with what? 1/3 left over, yes? We'll get into subtraction and addition, but you should have already got that under your belt because you watched the Khan Academy videos. So, and God help your mathematical soul if you didn't do what you were told to do. So we know that 3 over 3 equals 1, so that's the same as saying 1 with 1/3 left over. And how do we know this is correct? Well, we take a mixed number and we turn it into an improper fraction, which you're going to do that a lot. Let's change colors here. We'll go to red. All we got to do is multiply 3 times 1, and that gives us a 3. And then we're going to add that number to the numerator, what's left in the numerator, and what does that give us? That gives us 4/3, and we're back to where we started from. Okay? All right, good. I'm glad we're all on the same page. Okay. Now remember, math is nothing but a language. You just have to learn the base of the language. It's nothing, no different than Spanish or English. Well, English really isn't a true language, but we'll say Latin or Greek or Spanish or French or German. Okay, well, let's clear all this off. Let's clear all this off. Hello. There we go. Let's clear all this away. All right, let's start over again. Let's go back to black. Okay. So, we need to look at how these are. Now, in engineering and machining, we don't deal in fractions a lot. You do in carpentry because your tape measure's based on fractions, 1/16 rule or whatever else. Because your measuring instrument, the degree of precision of your carpenter's rule is 1/16. That's the smallest division of the measuring instrument. In machining, we use measuring tools that are in 1/1000ths and 1/10,000ths. So our degree of precision in machining is 1/10,000ths of an inch. So we'll get to that in a little bit. Well, let's talk about another aspect of fractions, and we call that the decimal equivalent of a fraction. Now, some math people will call a decimal fraction. Well, it is a freaking fraction. It's the decimal equivalent. So we'll just refer to it as the decimal equivalent. And in your exams, when we're doing the fractional answer, you will give me 2 answers. You'll give me the fractional answer, and you will give me the decimal equivalent. All right, let's start off with the degree of precision. We'll introduce that. So we're going to go, well, no, we're not. All right, let's go over and get the marker again. Marker, go down here to black. All right, here we go. 1/2. So that is 1 to 2. 2/2 equals 1. This is 1/2. Half of a whole, which is based on 2. Now the decimal equivalent of that, if we divide 1 by 2 with our calculator, we get 0.5. And if you don't believe me, you can do that yourself. You can come over and we'll get the calculator out. There's the calculator. 1 divided by 2 equals 0.5. You'll notice there's only 1 decimal place here, right? Okay, as opposed to 1 divided by, let's say, 128. How's that? Wow, got a lot of decimal places. 1, 2, 3, 4, 5, 6, 7 decimal places. That's a pretty high degree of precision. Okay, there's the 10th, 100th, 1000th place. The 10,000th place is right here. 10,000th place. The 100,000ths. Excuse me. And then we get into the millions and stuff like that. Down here in ridiculous land that we can't measure with our hand measuring tools, even in machining. All right, so we'll close that out. And then we'll go back over here to our decimal equivalent. So we divide 1 by 2. So 1 over 2, low common denominator. You've probably heard that sometime by your evil math nun. I don't like low common denominators. I don't like people that think like low common denominators, because you get a low degree of precision. This is only 1 decimal place. Now, let's say we have 1 over 4. 1, that's a 1. That's going to equal what? 0.25. If you don't believe me, do it on your calculator. Well, we've gained a decimal place for a degree of precision, but as a machinist, that's still not good enough. About 1 over 8. 1 over 8. What does that give us? 0.125. Wow. Okay. All right. Pretty sloppy. All right. 0.125. Okay. That's still only 3 decimal places. And that number's 5. So you could argue that we'd round that to 0.123, but it's really not. So it's really still not a very high degree of precision, even though we're in the 3rd decimal place. How about 1 over 16? Let's go 1 over 16. What's that? Yeah, you in the front row. What's the answer to this? Oh, that's right. This is online. It's a video. There's nobody in the rows here except me and my imaginary friend. 6, 2, 5. Wow, look at that. Now we're in 4 decimal places. Tenths, hundredths, thousandths, and we're in the 10,000s. Now, if you have a digital caliper, it will read most likely to 3 decimal places, and you'll get a 4th decimal place. It'll be a 5, or it'll round this over to this, or it'll be under 5. It won't show up. Okay. Now, if you have a digital micrometer where the degree of precision is 1, 2, 3, 4, in other words, the degree of precision on the instrument would tell you that your instrument degree of precision, this will be marked on your measuring instrument, then you know that the smallest increment that will measure is 1/10,000th of an inch. 1/10,000th. That's tenths, hundredths. In other words, that's 1 over 10. That's 1 over 100. That's 1 over 1,000. And that is 1 over 10,000. Each one of these goes by a factor of 10. Okay? All right. So let's get rid of that. I can probably just erase it. Yeah. Well, we're wasting a lot of time here. Here, we'll just select it. We'll select it. Hit the delete key, get rid of that. Come over here. We'll select this. And get rid of that. Boy, I'm really messing this up, aren't I? Well, okay. Now we can erase this. All right. Okay. So that's 1 over 16. What about 1 over 32? Go back to the marker. Oh, my goodness. Problem with having 2 screens. Marker. Black. How about 1 over 32? What do you think that is? Well, that'd be half of that, wouldn't it? If this is twice that, then this is going to be a half, right? That'll be a half. So let's go. If you don't believe me, let's go to the calculator. Where is the calculator? There we go. Bring the calculator up. 1 divided by 32 is what? Yeah, 0.3125. 0.03125. 0.03125. So that equals 0.032. My ADD's kicking in. 3.125. I love it. All right, 0.03125. Right? And then how about 1 over 64? Well, we'll put the 1 over 64 over here. 1 over 64 equals what? It'd be half of this, right? So what is that? Don't be afraid to use a calculator. And don't be afraid of big numbers in the denominator. Don't be afraid of big numbers down here. You have a calculator, use it. 1 divided by 64 equals, oh my goodness, 0.015625, right? 0.015625. So we've got 0.0. What is it? 0.015625. 156.25. Okay. So we have how many degrees of precision here with the denominator of 64? 1, 2, 3, 4, 5, out to 6 decimal places. Okay. Now, if we said we wanted to go to only 4 decimal places, 1, 2, 3, 4, well, we would round just to 4 decimal places. And how do we round numbers? Well, we look at, if we're going to 4 decimal places, 1, 2, 3, 4, we look at the 5th decimal place. 5th. Since that's a 2, it's not 5, it's less than 5, we would ignore it. We would ignore that, and it would just be 0.0156. If we were going to go to 1, 2, 3, 4, 5 decimal places, then we would look at the 6th decimal place, and we see that that's a 5. And so then, since that's a 5, since this is a 5, then we would round this up to a 3, and our final answer would be 0.01563 if we were going to only go to 1, 2, 3, 4, 5 decimal places. Only 5 decimal places. So that's the degree of precision. And you'll notice that as we get larger in our denominator, we get a more precise output. And it's the same way in life. It's the same way with people who think in a low common denominator. If they're all thinking in just yes or no, or you or them, or us and them, Democrat or Republican or whatever, we get a very imprecise output. It's only 1 decimal place. If we get a lot of people down here in the mix, a lot of numbers in large denominator, we get a higher degree of precision on our output. And that's what we want as machinists and engineers, the highest degree of output. And we should in our own lives too. We would like as many data points to make up the whole. That way we're more precise in what we're doing. Okay, so enough of degree of precision. Now, later on in your machining career, you'll understand what the degree of error is. But let's go back and let's say that we're using a micrometer and it's good to 1/10,000th of a place. 1/10,000th. So that would be 0.000001. See, 10, hundreds, thousands, 10,000. So the degree of precision and this will be marked on your measuring instrument, or it'll be your output. How big is my string of numbers? How many decimal places do we really need? Depends on how precise we want. So let's just say we're going to go to 4 decimal places. Excuse me. 1, 2, 3, 4. This is the degree of precision. So our degree of precision is 1 over 10,000. Our degree of error, however, is plus or minus half of our degree of precision. So in other words, our degree of error, we'll call this the degree of error of this number would be 0.00005. It's half of that, right? So that means theoretically, if we're measuring something to 4 decimal places, we could err plus or minus 0.0005. So if we measured something exactly at 0.00001, our number could be as high as 0.00015, or it could be as low as what? What's 0.05 minus this, right? What would that be? It could be as low as 1, 2, 3, what? 4, 5, right? Isn't that right? If you don't believe me, come over here to the calculator. So we've got 0, 1, 2, 3. There's our 10,000s. And we're going to subtract 1, 2, 3, 4, 5. Yeah? So what do we get? Oh, wow, Mr. Wizard. We get that. Isn't that what we got over here? Of course it is. Of course it is. Okay? So, theoretically, if we're hand measuring this, our number we could measure as high as this, or we could measure as low as that, assuming that we actually measured just this. That was what we measured. Now, those of you who've done machining before can see that this is really plus or minus 0.00005. We call that bilateral tolerancing. So we have to have a tolerance, or we'd never get a part accepted. We probably ought to put a 0 in front of the decimal. Yeah, there we go. All right. So you'll learn more about this in blueprint reading. So I think you understand that the larger denominator gives you the higher degree of output in your numerical. And if your measuring device is a 16th or a 32nd or a 1/10,000th, you can measure more precisely than if it was just a half-inch gradient. And this is all you're going to get, right? So, all right. So let's pause the recording for a minute. All right, we're back. Well, let's clear off our screen. Select. Probably didn't catch everything, but that's all right. Yeah, we got one little gizmo over here we'll get rid of. Okay, there we go. Go back to our marker. Black. All right, so how are we going to add, subtract? Okay. We're going to add 1/4 to 1/3. Now, make this easy on yourself. Now we know that 4 and 3 equally go into 12. But let's say you didn't know that. Let's say you did not know that. The simplest thing to get the common denominator to add, because if we're going to add fractions, we have to have the common denominator. I can't add 1/4 and 1/3. Unless, of course, I reduce them both to decimals, and then I could add that. But if the answer is supposed to be in some kind of fractional form, you're going to want the fraction is going to have a common denominator. So let's just pretend we stay in fractional land for a while. So the easiest thing to do in all cases is multiply these two down here. Multiply that times that. We know we get 12, yeah? Okay, so we know that 12 is going to be our common denominator, right? So 12 is our common denominator. So now, 3 times 4 is 12. What we do down here, we have to do up here. Okay? So, that's 3 times 4 is 12. 1 times 4 is 4. So, what about 4? We got to multiply 4 times 3, right? And what we do down here, we have to do up here. So 3 times 1 is 3. So that's 3 12s, right? 4 times 3 is 12. 3 times 1 is 3. So 3 plus 4. So that is 7 12s. And that's your answer. Except if this was a test problem, you would give me 7 12s, or 7 in some fraction form. And then you would reduce that to a decimal equivalent. And remember, all you got to do is just divide 7 by 12, 7 divided by 12, and you end up with, oh my God, 0.583333 out to silly land, right? Okay. So, what was that? 0. Here, what was that? What was that? 583. Yeah, here we go. 583. All right. 5, 8, 3, and we ran out of paper. But that mark means it just goes on forever until we all get tired of threes. All right. So that's how you add fractions. You got that on the Khan Academy video. Let's do a subtraction. Let's do a subtraction. Let's subtract. Well, let's change here. We'll change colors. Go back to black. Let's subtract 1/3 from 1/4. Now we already know the secret to this recipe, right? You already know that. We know that the common denominator is going to be 12, yes? Okay, so it's 12. It's 12. All right, we know that what's this going to be? This is going to be, is it easier if I do this in a different color? Here, goodness, I've lost my cursor. There it is. I need to slow down, is what I need to do. So we know this is going to be 3, and this is going to be 4, right? All right, so over here, we're going to put 3 12s minus now 4 12s, right? So we're going to take 4 from 3. Well, our answer is going to be negative. It will be a negative, what, 1/12? A negative 1/12. Well, subtract, go to your calculator if you don't believe me. Subtract, put in 3, subtract 4, and you'll get a negative. You put in 3, you're going to take 4 away from it. You're taking more away than you had. And oh, we get a negative number. Oh my God. We're in hell, right? We're in math hell now. You were probably told by your evil math nun in school that a negative number is an imaginary number. Well, they lied to you. They also told you when you were younger that there was an Easter Bunny and a Santa Claus. There's nothing imaginary about a negative number. This just means it's going in the opposite direction. If you're a mechanical engineer and your pressure goes negative, then you pulled a vacuum. If you're a structural engineer and your stresses in your analysis go negative, you're in tension instead of compression. And you better keep track of whether it's negative or not. If you just gave me an answer of 1/12 here, you would get the wrong answer because it's not 1/12. It's not a positive 1/12. It's a negative 1/12. And if you don't understand your negative directions, you're going to crash a $1 million CNC machine or tear up a manual machine, and your boss is not going to be happy. So really, what does this mean to us? Well, I'll tell you. Let's start over here with our Cartesian coordinate system. Now, this is named after a French philosopher by the name of René Descartes in the 1600s. And he coined a phrase. In Latin, it's cogito ergo sum, which means if I think, I am alive. I think, therefore I am alive. Cogito ergo sum. Now, I already told you that Euclid, in about 300 something BC, stated that the laws of nature are but the mathematical thoughts of God. And I've already told you, I don't care if you believe in God or not. I don't care what you think of God, whether you think God exists or not. But that was what Euclid said. The laws of nature are but the mathematical thoughts of God. Now René Descartes, we'll watch a video. I'll post a video on René Descartes, and you'll watch that. It's a very short video. What René Descartes did is he took geometry that Euclid put together in about 300 BC and his 13 elements of geometry, and he put the equal sign, algebra, with it, and came up with this XY system. And we already know that there is a third dimension to this, and that would be Z. And all of us machinists and long-range precision shooters and artillery people know that about the X, Y, Z Cartesian coordinate system. But since this screen is really only in 2 dimensions, we will ignore the third dimension. We'll ignore the third dimension. Where's my cursor again? There it is. We'll just deal with 2 dimensions for right now. Now, later on, we will get into 3 dimensions, and you can't ignore that. You won't be able to ignore it. I won't let you ignore it. Well, you can ignore it if you want. This is America. You can do whatever you want, but you'll get a bad grade, a very bad grade. All right. So, at the center of the coordinate system, we have 0 and 0. Now, the Europeans wanted to go to war over the 0. The Mayans didn't have a problem with the 0. The Arabs didn't have a problem with the 0. And the Chinese did not have a problem with the 0. What the Europeans did, they got over it. So, if this is 0, so everything at the center is 0, 0. 0y and 0x. Okay? And we might as well throw this in there now. You always write it x, y, and z if you're dealing in 3 dimensions. So in this case, it would be 0x and 0y. 0x, comma, 0y, and it'd be in parentheses. And that's the coordinate in 2 dimensions for that center right there. This way along the x is positive, and this way along the x is negative. I'm going to put a little arrowhead on there. This is negative, okay? This way along the y is positive, and this way along the y going down is negative, okay? So really, it has the same value, this negative 1/12th, as if it was over here, except it's not. It changed directions. It's going this direction, this direction. If we're going in this direction, it's negative. So doesn't mean it's imaginary. So you get that, you get over that. It's not imaginary. It's just going in the opposite direction. Okay. Now we could have said this was Z and this is X. If we were standing in front of a milling machine, the turning tool is on the Z axis, and then Y would be this way. But for in this case, we put this as Y and we put this as X. This is the roadmap. This is what you need to look for. Okay? All right. So there is how we subtract, and you should have got that from the Khan Academy videos too if you watched them. All right. We'll play more with this in a little bit. So the negative is extremely important. Do not forget this negative. If you do, you will get a wrong answer. You will get a wrong answer. Okay? Now let's run over and recap multiplication, and division. So, for adding and subtracting fractions, what do? We have to have a common denominator. Yep, adding and subtracting. For multiplying, though, multiplication's easy. Oh my God, it's so easy. All right, let's say we have. Let's just. Well, hello. Let's escape. Go back to our brush. Go back to our color. We're going to multiply 1/4 times 1/3. Now this is simple. Multiplication of fractions is so easy. Oh my goodness. It's just super easy. Super easy. Multiplication, all you do is you multiply the tops and you multiply the bottoms. So 1 times 1 equals 1. 4 times 3 equals 12. Yeah? So we're not adding them, we're multiplying them. If you had, let's say, 6 over 3 times, I don't know, well, we'll just say 3 over 6, whatever. 6 times 3, 3 times 6, so that's going to be 18 over 18, or it's 1.0000. We'll go to machine land. We're working 4 decimal places. Okay? All right. So that's all there is to multiplication of fractions. Now we'll get into orders of operation later, but let's see here. That's really all I can't make this any harder. It's just simple. We'll do another one of these if you want, but I think we need to go back to subtraction and addition, though. Yeah, we'll go back there in a minute. After we do division, we'll recap, and then we'll close this overcap of the video out. Now, these videos, you can play them over and over and over again. So let's do division. Let's say we want to divide 1/4. That's the division symbol. We want to divide 1/4 by 1/3. Now that's the same thing as saying 1/4 divided by 1/3. Yes? Right? So what you do is you take the reciprocal of the denominator. What you're dividing this by, you turn this upside down. So this becomes 3 over 1. And then you multiply that times that, right? So that becomes 1/4 times 3 over 1. Yes? We turned 1/3 upside down. It's 3 over 1. We put it up on top and multiplied it. And what did you get? Ah, you got 3/4. Wow, isn't that cool? Right? So, to make sure we don't forget how to do that, I want to go back to a pet peeve I've got. That means y'all need to pay attention to this. Okay, let's go change our color back to black. Let's say that we have some crazy numbers. It doesn't really matter what it is. Okay, let's say we're going to add. let's say we're going to add. We're going to add 1/4 to, I don't know, 127. See, if I put 128 down there, you say, oh, hey, Mr. Wizard, that's an even number on the end, so we can divide that by 2 and get it down to 4, because 4 goes into 128. What, 32 times? Right? So, again, make this easy on yourself. You have a calculator. You have a calculator. So the common denominator is going to be, we're going to multiply these two together and we're going to come up with a common denominator is what we're going to do, right? Okay. So we're going to multiply these two together and we're going to get a common denominator. And what is 127 times 4? What is that? 127 times 4. 127 times 4 equals 508. Don't be afraid of big numbers. Don't be afraid of this. You got a calculator. Okay? You got a calculator. It's okay. It's okay. So, what was that? Oh my God. My Alzheimer's is kicking in. There we go. 508. Okay. So, we know that our common denominator is 508. Because in real land, when we get out of silly fraction land, we're going to be doing decimals anyway, right? So, all right. So 4 times 127 is 508. And we know that we multiplied 127 by 4, right? And we multiplied 4 by 127. So here we go. So 4 times 127 gives us 508. What we do over there, we got to do over here. And I made it easy on us. We just put a 1 there. So that's 4 plus, and then we have to multiply this times what? 127 to get 508. So we do this 127. So, right, 1 times 127 is 127, right? 127. I'll make that a real 7. All right, so 4 plus 127 is, what is that? 1, 3, 1, right? 131. Double check my math. Better double check me with that calculator. 4 and 7 is 11, right? And we'll carry the 1. So that's 131 over 508. So we're almost there. We're almost there. Now we don't have any measuring devices that are busted up into 508 little marks. So we've got to convert this. We have to turn this into a decimal equivalent. So you get your mighty fine little calculator out. And we got 131 divided by 508. And we end up with this ridiculous number. Oh my God, look at all those decimals. Man, I'm not going to count all those. Oh my God. So, how many decimals do we need to own? Let's say we go to 5 decimal places. 1, 2, 3, 4, 5. And then we go to the 6th. and we see the 6 decimal place right here is at 4, so we'll leave it alone. We'll ignore all of this over here. Now, if we were going out into space or something and we needed all these, then we would use them all. But for us today, we're just going to go to 1, 2, 3, 4, 5 decimal places. We looked at the 6. We don't have to round that. So it's 0.25787, right? So it's 25,787. So we'll go back over here. Go back over here. And that's 0.280. Oh my God. I can't believe this. 257.87. I love it. 257.87, right? Did I even get that right? 257.87. 257.87. Yeah, looky there. So, this is our answer in decimal land. That's our answer with how we did our fraction. And then this is the decimal equivalent. So on the exam that you'll eventually take, you'll give me a fraction, and if it's a long calculation or something in fractions, then your fraction may be, your decimal, I mean your denominator may be a little different than mine, but as long as the decimal equivalent is the same and I don't have to do the math for you, then this will be the correct answer here. And this is what we want as machinists and engineers. Okay, this video is now at 46 minutes, and we're going to cut this one off. We will pick up with more complicated fractions in the next video. And then, of course, that'll also be covered on the review. All right. So until we meet again, play this video back over and over again. And good luck.